everybody. So I had wanted to do a lab with you guys this week, but we are not in school, so I'm going to try something different. I'm going to do a lab on a video. I'm going to do 5 different demonstrations of chemical reactions. There's one for each of the 5 types of reactions that you have learned about recently. And for each one, I'm going to give you the equation that goes with it, and I'm going to have you do 3 tasks. Number 1, you have to balance the chemical equation if it's not already balanced. Number 2, you need to tell me, based on the equation, what type of reaction do you believe that it is? The 5 types were single replacement, double replacement, synthesis, decomposition, and combustion. You also need to list for me what evidences do you see of a chemical reaction taking place. The evidences of the chemical reaction included a color change, included energy being absorbed or released. That could be temperature, it could be light, it could be electricity, any kind of energy being absorbed or released. So we've got color change, energy absorbed or released. We've got a precipitate is formed, an odor change. I know you can't smell on a video, but I will let you know if there is a smell. You just have to trust me. Same with temperature. And also is a gas released. That one you'll know just by looking if there's bubbles and if it starts to foam, right? So those were the evidences of a chemical change that you've learned about recently, and you've got to see which ones do you observe. For each demonstration, balance the equation, say what type of reaction, and list the evidence that a reaction has taken place. We're going to go ahead and begin. Okay, for our first demonstration, this is your chemical equation. I want you to copy that equation down, and then we are ready for the demonstration. So we are going to burn some methanol for our first demonstration, and just for fun, we're going to add a little bit of boric acid. That is not actually involved in the chemical change, and in the chemical reaction, it just adds a little bit of color, which makes it fun. The primary chemical reaction is going to be burning ethanol, or methanol. This is the methanol. I've already got some in a little beaker, so we are going to add a little bit here. And we're ready to begin. Voila! Make sure you write down what evidence do you have that a chemical reaction has taken place. You're going to record what type of chemical reaction you think that this is, and you are going to need to balance that chemical equation. Okay, this is the chemical equation for our second demonstration. Please copy it down, and we are ready to get started. For this demonstration, we are going to combine sulfur and iron. This is a demonstration that requires heat to activate it. And so after I mix it, we are going to have to heat it up. Let me get it mixed up in here a little bit first of all. A little bit of that into the test tube there. Okay, let's get our heat, and let's try it out. So again, we're mixing sulfur and iron, which when activated by heat should form a new compound. You will need to specify what kind of a reaction this is and what evidence that there is that a reaction is taking place. Evidence right there. There's some good evidence right there. A few good evidences going on right there. Oop, get back in my flame. So again, you'll have to tell me what kind of a reaction this is, what kind of evidence there is that a reaction is taking place. Let's go ahead and take this off the flame now. They ended up looking like this. You got the nice yellow sulfur and iron powder all mixed together. When we end, you can see that what's on the bottom is no longer mostly yellow. It's mostly black. One other thing that you would notice, when we started we had two powders. At this point you can actually see the powders would be solid. You can see several different states of matter going on in here. And powders you would think would easily slide out of this. However, powders no longer slide out. So we've got this new concoction down there at the bottom that's just kind of stuck there. I'm actually going to have to break the test tube in order to get it out if I want it. But I don't think I want it that badly. Take a look at it that way. There it is. That's the end of demo 2. This is the chemical equation for our third demonstration. Please write it down and let's begin. In this particular demonstration, we are mixing magnesium chloride with sodium hydroxide. The sodium hydroxide has been mixed with water to make it an aqueous solution. The sodium chloride is already in an aqueous solution, so we have two liquids. This is my sodium hydroxide aqueous solution, that's that one. So we're going to go ahead and add our magnesium chloride and be ready to watch what happens. Okay, that was a pretty fast reaction. Okay, so now I have clear fluid with this white powder floating inside of it. We know it's a white powder because if you look very carefully, you can see on the side some of the powder actually splashed up. Can you see that on there? See some of the powder actually splashed up? So I started with two clear liquids, and from two clear liquids, now I have a clear liquid with a white powder inside. Demonstration number 3. Two clear liquids yields one clear liquid with one white powder. The end. Okay, so now that this has had a chance to settle a little bit, you can see the white powdery substance that's a solid has sunk to the bottom because it's more dense, leaving the clear liquid up at the top. So white powdery solid sinks to the bottom, clear liquid stays up. There it is. Here is your equation. Make sure you write it down, and we're going to go ahead and get started. We're going to be mixing copper sulfate. This is a solution of copper sulfate with water, and it's a little bit warm right now, so you can kind of see steam coming out. That's a solution of copper sulfate and water. We're going to be mixing it with iron. Here's my nail, hopefully made of iron. We'll find out in a moment. See what happens. And we've got an iron nail in there, and we are stirring. I can actually already see the reaction taking place. Check it out. Do you see that? Let's stir a little longer. But what evidence do you see that a chemical reaction has taken place? I started with a silver nail. You can see the top of the nail is still silver, but the part that was mixed in with the copper sulfate has turned a different color. So here you can see some of the copper actually comes off on my hands. That's copper dust on my finger then, and it was scraped off of the nail from the top and from the sides there. You can kind of see where the copper has been removed now, and underneath is what's left of the iron nail. And so that's copper. So that was copper that was formed in that reaction then. This is your chemical equation for demonstration number 5, our last demonstration. Please go ahead and make sure you write it down. As always, you're going to need to balance it. You're going to need to identify what kind of an equation or reaction that it is, and what's the evidence that a reaction is taking place. So in this particular case too, just as a heads up, that acid is written up there because the acid is the catalyst. Just something that causes the reaction to take place. Okay, that's all for that one. For the reaction, and then that is going to yield carbon and water. Get it all stirred in there nice and good. What evidences can you see that a reaction is taking place? Remember, in this particular case, the acid is our catalyst. It's what causes the chemical reaction to take place. But the chemical reaction is just the sugar becoming carbon and water. Alrighty, here we go. So, what evidence do we have that a reaction is taking place? Okay, so you can definitely see water vapor being released and condensing on the sides of the container. You can also see a black crunchy solid being left behind, and man does it smell, and it burns my nose. Oh, that's hot. That's definitely warm. We've created some heat here. I think I'll leave that one for a little bit.